So, hello everyone. Today we start with the first tech tutorial of DSC ADRIA, which is going to be consideration what AI solution to use, delivered by Catalin Gheorghiu from Apple Systems, who is right now, I think this is your fifth or sixth DSC event happening already. So thank you so much for coming back. What I can say that as what you're going to understand here is that AI is making inroads into visions. And let's see what are the most obvious options are: custom vision and ChatGPT vision. This presentation will aim to show you the ropes of these technologies and what are their faults and shortcomings. What is going to be covered in this tech tutorial is Azure AI Custom Vision, Azure OpenAI Service, CAN, Microsoft Open Source Cube AI Application Nucleus, MEC Application Solution Accelerator. And what is also important thing to say that we are going to get the feel of these technologies and get them through the pace as much as possible. That means that you will have a lot of demos on the end and some Kinder chocolates. I'm very looking forward to see what is going to be happening here. So thank you so much, Catalin.
Unfortunately, because you are a remote, won't be, but I'm hoping the next time we'll do it in person. So yeah, that would be good.
I will just kill switch my video and tone, and Catalin, you're the man right now. So thank you so much.
Have a nice, good morning, and let's try to get started on this. I have 1.5 hours to run through these materials. Also, we need to pay our dues to the demo codes, and you will see. The session is consideration on what Vision Solution is. As you disregard the EPAM proprietary confidential, I was let's say it was told from my company that if I'm doing the sessions and if there is no conference templates per se to use this, and this unfortunately, and I only now I said. So my name is Catalin Gheorghiu. I'm working as solution architect at EPAM system. From the year 2011, each year Microsoft awarded me the title of most valuable professional. I'm also a current Microsoft certified trainer. So this would be about credentials. Okay, that was wrong put in this session. But still, I got your attention because it's it's a business session. I should not do this like we're talking with Alexander a couple of seconds before. We're to be in the Arab country, or we are having somebody from the government. But this slide, it's what we could generally think that it's custom vision. Terminator. Yes, I'm that old. 1984, just showing some code on some image. It was, let's say, it was what they thought that it would be the future. Getting back, custom vision, getting back to reality at the present time. Yes, the Skynet is on. Custom vision, it's, I believe, the only technology from the IE arsenal which is really widely used. And I'm going to try to show you how, why, and the hows, the whys, and also try to put something end to showcase this. I hope that we're going to have enough time. Unfortunately, we are not that much interactive. I'm talking to a screen and to a camera, so I cannot ask you if I should go with all the details and minutiae of how this stuff usually is working. So we'll get rid of the slides because yeah, I'm not there. Let's try to get first the concept. If we are talking about custom vision, we have something like 5 concepts. I'm using this website. And there is something related to Raspberry Pi I never used, but it's a very nice presentation. I show it all around the conferences. So what are the terms? Classification. Classification, unfortunately, here it says the single object. What is classification? It means that I'm throwing an image like the eye, and they will tell me if I have an object there. Does not matter where, but this works also multiple objects. So it will work also if we're doing to the image below. I'll try to, let's say, this does not. It will give me the list of persons, but not where there are, which is, yeah. Localization means that I have the bounding box. This is the biggest concept of bounding box. Everything where it's detected should have a bounding box besides classification. On detection, yeah, we have the bounding box for each and segmentation. Segmentation, it's the, let's say, seldom used in normal scenarios. It's try to get the right contour of the object. I'm going to talk about also the mathematics of these bounding boxes. To understand another stuff, generally, the models do not work on moving units. They work on static ones. So if you are pushing the data to a model, you need to first internally in the tool, whatever you use, slice it in frames. And then to run the model, put the bounding boxes and labels. Here the issue will be, let's say, taking the examples, the one with the detection. Here, if the model is trained only for between the frames, you will need somehow to know that it's the same person, the same bounding box between frames, even though the dimension change a bit because of detection, because it's abstracted, to know it's the same one. I will give you, let's say, unfortunately, rather actual scenario, which is, if which you find it on the internet, it's detecting drones. So if you are detecting something, you know that you need to know that it's the same thing in frames. But we'll get back to it. We're talking now concepts. Also, this side, because again, I do not know your background. So that's where we have a normal process of doing creating this kind of solution. It's something like this. We're gonna create images for capture. We need to have an annotator, which is process called later. I'm gonna show you how to start this. And with this, we train the model. We are then maybe capturing new images during the production, during the work of this retraining. But generally, okay, we train the model, and at this model, we're throwing images and get replies. The replies are, I'm going to show you this also, are usually in a form of JSON XML. So you are getting the label and bounding box, something like this. What is changed with ChatGPT? Okay, it changed that you already have the models. And also, ChatGPT is oriented to speech. And being oriented to speech, you need to ask him question. Also, by the nature of it, here is the biggest difference around. It's that it hallucinates. The normal models will give you, will give you an answer. They always give you an answer. Mike is here. So let me double check if I'm not seeing the question, but check one.
Try with this one. This one should be better, I'm hoping. Getting back to the topic. In both cases, you always get some kind of answers when you throw from the model. But the normal one, you get a probability, i.e. does not deal in certainties. Let's see. Much better. Okay, wonderfully. At least something I did solve. So does not deal in certainties. They're percentages. So you need to have something like a higher percentage of probability, and then you are okay. A lot of talk. I speak for something like 20 minutes. So now I'm gonna speak a bit more, and then we'll move on to really try to show you something of this. Again, I'm trying to show you. Here is the picture. I did not. Yeah, this is the picture. Now I'll try to. What is the problem with the prompts? Now I'll give you the scenario which it's a work scenario that we solve very easily with custom vision. And we'll talk about what is to use. So the short scenario is we have a server room, and we wanted to know the temperature. Yes, we have from the servers, we have a lot of sensors, but we needed the whole room. But the normal idea is to put a dedicated sensor, to put the cabling, to get it somewhere. The second idea is that we already had a security camera covering the server. So we just put a thermometer on the wall and read the stuff through custom vision. Okay. We use the normal custom vision. So we took a lot of images and we trained the model. And also we have put filters to ensure some consistency. Yeah, we're gonna talk again. What are the issues with color? Because okay, we'll have our 5 minutes talking with. Here we see that it's very hard to demo, to entice a custom vision, which is even now hard to show because of the problem of accessibility. To get access to custom vision in normal price and stuff like this, and then to make it hallucinate. The problem with the generative models today, it's they are prone to hallucinate, and you need to get rid of this. You'll hear about this topic a lot in this conference, and there are a lot of great resources of how to avoid it. Sometimes it's worth it. Sometimes you can use the simpler way of doing things. So this is one of the examples how you do it. Okay, so let's move on. As you already understand, these models behave much more like an API. So you have an API, you throw something, an image at it, and you get a reply. This could be done in 101 ways, but I picked something like two already prepackaged way, in which we were getting the components in. So we are getting the cameras, we are getting whatever processing power we need to allocate. And we're telling you, please use these models. And then we're just getting the feed of data. And this to be done as easiest and as painlessly as possible, without writing a lot of code, in fact, without writing at all code, and so on and so forth. My options were from Microsoft, because this is this is my world. Yes, they are not the only one, and in some points they are work in progress. So we're talking about two open source projects. The first one, which is the okay, let's get this in. This is not what I wanted to show you. This I will gonna show you later. The first one, I'm doing this because I have some toolbar up here, so I cannot click. The first one is Khan, and which is the very, very dreadful name of CubeAI application nucleus for Edge. And this is the one I'm gonna show you the most. We're having this also in production. I'll say the experience, it's rough at the edges. So it's, and this is why I'm gonna show you, not because it's rough at the edges, because it's still in pretty much, it's somebody's working into it. So, and also it's very easy to install, relatively. I won't say in minutes because there are issues. I'm not big, but I'm gonna tell about it. I'll tell you about it so you can avoid them. Yeah, and when you know the idiosyncrasies of the tool, you can really use it quite easy. So let me get to the next page to show you a bit the architecture. Okay, this was the setup guide. This is the architecture, and again you see the background. So I was saying, you are having the cameras, they are thrown in, and yeah, you are doing your magic on it. And I will show you that you can get the magic from anywhere, and they get you the results. To understand and make it simple, we are, let's say, we're living in a world of cameras. We're surveyed each and every second. And what is quite interesting is that all the cameras have know a couple of protocols. Let's say one of the most common one, it's RTCP. And yeah, this Khan knows this protocol. It's not the only one, and it's not the most modern one. But any camera, you can get it to run on top of this. The other one, again, from Microsoft, it's there are 5G solution accelerators. As you see, it's again, it's a Kubernetes solution. It was also updated last week. but it's did not had that much change, and it takes a bit more to install it. Architecturally, it's not dissimilar. Okay, here you see that you have the frame splitter. They somehow are not oriented to go on the edge, as Microsoft was considering edge before. It's a absolute Kubernetes solution, and yeah, in a way are similar, in a way are dissimilar. This is a bit heavy, and you need to know a bit much more Kubernetes. Let's see. That will be a Khan install, but let's get from the very beginning. Let's talk about where it was. Because I opened the installation. If not, we're gonna, we're gonna do it here from the minutes. In fact, we're not on the good one. This one. This. That'll be the current setup guide. If it has the right rights, it will know to show you everything. I'm not doing this step because this will take time. Not that much installation. To create I usually create beforehand, and this is working better. I create a IKS cluster. That it takes in around 10 minutes. The last part of the demo, which it's let's say the most important, takes 2 times 40 minutes. This is not part of the Khan, but part of my setup. I'm creating a VPN. To understand the issue, which in the real world it's very well solved, each camera must have an IP address. Usually it's v4. I rarely seen cameras with v6, if any. Because, okay, it was a scare. There are no IPs because the big giants bought IPs. Now they are released, and it seems that the pressure somehow was alleviated. This getting back to the topic, it's that yes, you need to get from a known IP to the cloud all the information. And because I'm using my laptop camera or another camera connected to the laptop, somehow I needed to fix and publish this address. That was the VPN. And this takes to do these steps in Azure Cloud 40 minutes. And okay, getting back to the script, usually everything it's straightforward. The only stuff that you need to not do is to use a custom role. You need to say no. And everything will work pretty fine. I've tried all the variation. Also, it's recommended to use AKS, but you need to change the size of the clusters because this is why I say in documentation. They do give a heavy reason. It's a downscale. Bear in mind, this is not used for training. We're going to cover training when you get there. So let's see, when we run this, I'm guessing this one it is. This is what we get. This can be secured. You have documentation, but for demo, it did not matter to create everything and anything in also this security. So it's better for me to be open. You have the steps to lock it down. So it can be used in production. Okay, this part is configuration, and let's run to the pain of it. In fact, let's try to do a solution end to end. So what I'm not gonna create, but I'm gonna show you how it gets done. It's a device. So we have here an IoT Edge device, a Kubernetes device. By IoT Edge, it's the what Microsoft talked before with IoT Edge. It means something connected to the IoT hub, which again run containers on the edge, and the deployment is done through IoT hub. It wasn't, it's used, but it's not that widespread. So usually we are using Kubernetes. Again, Kubernetes, you can run it everywhere, but the management of it, it's controlled to normal Kubernetes way, pods and stuff, not going through IoT hub. So what you need to give it a name, and because this one not gonna create. You can say the current cluster, and in theory, and this is especially important if you are running on the edge, knows a couple of chips for inference. So it knows the NVIDIA, and it knows how to use a CPU. On the other hand, again, if you are running Kubernetes or something powerful, it doesn't make that much difference. If you are working on a constrained device like Raspberry Pi, like in fact, or try to augment it. Let me see. I used to have on my table. Yeah, I found it. Something like this. A neural compute stick. This is for running inference. Will make quite good even a Raspberry Pi of get a good performance out of it. And so said, if you are using cluster, enough processing power won't make a huge difference, especially if you are not having a lot of cameras. So let's do review and create. This is all that you can do. I won't create another device. I do not want to tempt the devil. Usually you won't need more than one. You'll have one deployment, you have one flow. I'm going to show you all the flow, and you have more cameras. And pretty much how this is how it goes. Then we'll have the cameras. Okay, you see me a bit in the earlier, but let's this delete. As a rule of the thumb, you generally cannot edit nothing in this portal. You won't get a crash, but it won't be saved. So generally, you just delete the stuff and create it again. Okay, we need to go to deployment because I test all the stuff. In fact, let's add another camera. So you see, these are the parameters which are in. Again, if you are familiar with Azure World, you'll see that everything is tagged. You have a lot of tags, and if you are to start digging in what's deployed by Khan, sometimes it will help you. So what we have here, we have the name, which it's nothing. It's just the name. We have the RTCP, which how it goes. In the RTCP, I can have also user and password. So this, if I put the RTCP string, this will be breakdown. The RTCP full, and here the user and password. We have the computer devices, and we have the location. Another hole on this, it's that you cannot edit locations. You just add them. and they are not using nothing, as far as I see. So whatever, it's a dead field. So let's if we are here, I'm going to show you a bit of the setup I'm using to, in fact, I will try to use to get my camera, one of the cameras to Khan, and to see if it works. So first I created that VPN. I'm going to show you that will be, I'm connected to that VPN. This is, I'm connected to the virtual network of the Kubernetes cluster. They have a virtual network, and I have a direct VPN connection to that. And then I'm use the most common, I'll get rid also of the slides. So, and show, and I'm using OBS Studio, but this is not enough to send you this. Oh, so it seems something it's working. So again, I will need to try to somehow move it because I need to get the menu. I install also RTCP server. So this is another tool, nothing out of the ordinary. I just need to start it. And okay, so now we are streaming. To understand, you see me now from the camera. It's a better camera, which is connected to the laptop. But what you see, it's the laptop on the stand showing to my dreadful desk and all the stuff. That we're gonna stream. Rule of the thumb, how do you see if everything is going on? So here it's VLC to rescue, but you need to know what to tell him. This, in my case, is pretty simple. I'm looking at ipconfig/all, and I'm combining. This is the local host, so it's 109. I'm open network stream. This is the one. Let's see if it works. If this works, it means that the camera, it works. And all the cameras which are around, as we see, yeah, it works. All the cameras that are around are working. They know to expose the RTCP string, and you can connect to them. Yes, sometimes you need to activate something or to do something, but you can jump in. So now we have the camera. We know the string. In fact, let me copy the where it is now, the IP, and we'll get, we'll put it into Mark. In fact, it's far easier to copy it from VLC. So network stream, this is the string, and we'll get back to Khan, which it's this one. So let's this is ADRIA. We'll put the RTCP, and we'll select this, and everything it's hunky-dory. Review and create. And this will create the camera. What it does not work, it's anymore. You are able to see the images as it goes. You see only the thumbnail, unfortunately. That's that. We'll let it this bubble and go to the next. Let's talk about stuff. The first stuff would be model zoo. We are living in the what are model zoos? You have out there pre-trained models. Intel, it's very known and having they having their own model zoo, which is pretty big. There also are generative models out there which you can get. These can use some of them. So, and to understand the term, if you have a library of ready-to-use models, this is called a zoo. We have here two GPT-4 models, which are pretty hard to trigger. So aggressive behavior and careless worker, I've tried them in venues, but were pretty difficult to use. And are the one from Intel, which yeah, will give you some results. This for sure. They are better for demos. What I must emphasize are two things. This is just apart from the model zoo. It's not a lot of not all the models, just a couple of them. And second, yeah, the problem with the models from Intel, it's I'll say, getting back to the colors, are trained with pictures from China. And the problem is it goes as follow. They are using color pictures. And okay, on models, there is something called observability, which is important, I would say, in banking, but also in this case. Observability, it's what characteristic of the object it's driving the recognition. To get the idea, the model number plates in China are blue. So usually in Europe, on our part of the world, will recognize only Serbian police cars. So what to get out of this, besides of the joke, it's that you should, it would be recommended to use it black and white. And also it's better not to have very high resolution cameras, especially if you are not looking to distant objects. Because you are complicated, has much more pixels to work with and color planes. If it's black and white, we are two. If it's if we are talking color, we are having RGB, 3 color planes. We have 1 color plane more and much more variation. And you need much more work to get the model well working and running. But still, this we're gonna try this with a model from the model zoo, but also can create a custom model. So here you see also that you can create a custom vision project. I created one already. We'll get back to it. What here you should do, you should create the model from here, not from custom vision, because there I'm going to show you, let's say it was the part on the login someplace. Yes, this one. So let's try to log in. It will be most probably on this one. No. One of my issues is that I have a lot of tenants. And my demo tenant, it's unfortunately very old and very strange configured. So let's see. Okay, let's try this one. So here it goes. If we're trying a new project here, you have a lot of variables. You can do classification, you can do object detection, multi-level, multi-class. Are the type of the models. The compact ones are the one that are designed to be run on mobile phones. So generally, you are running the model someplace in the cloud. You are throwing the picture at the cloud, and the cloud gets you something. The compact one are edge ones. So you are getting the model on the phone, and we'll go from it. If you are creating from here, you need to guess what it will do the CAN. If you are creating the model from the CAN and then get to it, it's a bit different. He will fix all these parameters for you, and then you can go. We'll get back to this EPAM detection. This is something pretty stupid. Say to detect the EPAM logo, which, as you see, it's also text, to detect it from places, and how the stuff it's going. You are getting here pictures. We are throwing pictures, and let's see if we have untagged. We have. So this is the labeling process. So you need to get the place and say that this is the tag, and so on and so forth. If the model is trained, you are doing here the training. You can also get a suggestion. It will try to guess the bounding rectangles. And this is, I would say, as friction goes, this is a very nice tool, as it goes. The other option, it's the normal label tool, which will do all the steps. Also, you can try throw the images that you use, that you recognize, back at the model to retrain it. It's doable. Here the issue is, okay, GDPR and some other stuff. And okay, here are doing training to understand as money goes. This one, I believe it's not uploaded. Yeah. Money goes, you have one, if you have the subscription, you have one project for free. But still, you need to have the subscription. The subscription, you find a free one. It's an Azure subscription of $200, which will run until you run out of money or 1 month. So to try it, you want to break the bank. Also, you can test here. Okay, improve your model. Here you can see the endpoint, which you can use in your code, and this is the performance of the model. It has quite a lot of images for only one label. Again, as tool goes, it's pretty good because it's integrated. And let's get back to our nice CAN. So on this model, we want, okay, we can create a new one. This is the type. You can also create as a GPT-4. And these are the labels. Okay, this part is not that... and that will create from you. Then we go to the part custom vision or the GPT to add the stuff, do the training. Here it's, let's say, just to show what it is and what are the options for the models and to create new models. How do we use them? It's AI skills. This is the part models AI skill deployments works in the manner that you always need to delete. You cannot edit. Okay, so let's still kill this deployment. To be able to create from zero an AI skill. So now it will let us delete and create an AI skill. So it will be skill DSC. Again, nose acceleration. Again, it's a question: what happens if you are running this in a cluster in cloud? It's generally CPU. But you see, this tool was synced to go even on NVIDIA Jetsons. So, yeah, but this is pretty standard, and this is the nice part. So, for sure, we have a camera input. Then we can run a model. I will move this. Let's see, what is the model type? I have an object detection. I'm still fighting with so strange enough, here we should see also the EPUB. You do not see it because we did not create the model. Now we see only the stuff in the. We're gonna create it later because this is the easiest one to try to see it running. And also we have the type. Let's use the person detection, so it knows already the label. So what else we need to do? This will be done. We need to filter. How I said, like everything, you'll get probabilities if you do not put any filter. In fact, this one, let us do it without filter. And you'll see how much data we're getting. This gRPC, it's to do some processing after you're running the model. And what else you can do with this? We need to take it out. Export video snippet, it's pretty clear. You have a storage account and you put it there. IoT Hub, MQTT endpoint, and IoT Edge module are internal to the deployment to the Edge module. So you only if you are doing deployment on the Edge, this will work. So for us are two options, and we can use them both. But in fact, we can put them both and use them both and connect them both. But for this, let's use only one. Export video snippet. Again, I'm fighting with, let's put the file in DSC _ snippet duration. How this works, when something is recognized, will get you 10 seconds of live video. So you go back to the live video, because I said this works on frames. Inside, it means that we'll put the bounding box, the label, and the percentage in the what will be the delay. And this is pretty much done. Again, as bug goes, I'm telling you, this does not work to edit. You just need to delete. So let's have DSC 1. Here you pick the compute device. What are the camera? So we'll use the camera we created before. And now we need to add the skill. So we can create a lot of skills and we can run it on the same input from the camera. So we added this skill. And then what else? Tag skill deploy. This will take a bit to start. Let's say deploying. And I need to look a bit around. We can click. If everything is okay, again, a bug, he put the same thumbnail to the both cameras. As processing goes, everything else is okay. And here it's let's say you do not see that it's clickable, but you click and you can see what's happened. Eye skills run. When you click it, let's see from this camera what happened. Camera inactive, it's again a bug. Here should display what's happening. It's not done. Insights, it's the content of the IoT hub. Since it's not a deployment, it's empty. Here will be the interesting part. Here, without going to Azure portal, I see the video snippets, and you can see what's happening. You see the percentage problem. The model recognizes a low percentage human beings all over the place. So for this, I'm gonna use a filter. But let us drop this if it's, and let's try to use the EPAM one, which it's let's say easier to test. We have here a mug, one used for testing. So we'll see, and we'll put some filter and hope for the best. And also we can try as endpoints goes. Endpoints are pretty simple. This is a pretty get something, and we can use an Azure function, and we'll add also this. And this is, let's say, the most relevant example to show you all this in one swoop. So let's create a custom model. So we have this project. You recognize what it's an object detection. These are the objects already. We review and create. Now we can delete this one and create a new ice. So let's put to work everything that we know. There will be DSC ADRIA. Skill 2. Now will be acceleration. Let's put CPU, this one. So let's run the ML mode. Let's see what we have here. So this was an object detection. And now we see that besides the model from the zoo, we have also a model. We do not want to capture retraining data. So I said before, you can take the data. This will work also for ChatGPT and also for the other ones. Don't. No. And let's add a filter. Let's put a probability of, first I need to put the object, which would be count of, then nice. Okay, it knows. And to put a confidence ratio, let's say it's 17%. And then we want to export the video snippet. So this could, let's say the shortest one. We want to insights and we want to delay the bug. And let us look in the portal. I've created the function to process all this. Now you see the I would say the virtual network gateway that I use, that I mentioned before. Let's see functions. I'm guessing it's not. This is a bug in the portal, even though everything is saved on the virtual network gateway when we're changing the address pool. It says that. So let's see functions. I'm guessing you are not interested in the code the function. It's a pretty stupid. It's nothing much. Now, if we have time at the end, I'm gonna show you even that. It's one project. I'm telling you, for all this demo, only the issues in Khan, which already solved, they are solved. So I explained it that you cannot save, you need to put no there, and creating the virtual network took time. The rest was pretty smooth sailing. It was under 1 hour and 5 beers to get around to do. So we can take this one. Please. And we'll put it in the, again. Where is the cat? And take. Now we will do a send to HTTP endpoint. So we can do even that. And we also can do more than one endpoint and stuff like this. And this, I'm hoping that will not crash everything. And now we have the skills. Let's do deployment. Get up with the test B. That compute device will become device. Become this one. ISTL. And review and deploy. And we could get what is doing this function. This function, it's taking what he receives and put it into a service bus queue. That's, let's say, a common scenario of doing stuff. Now we'll go to service bus and let us see if we have something. Up to now, until they did not deploy, we have nothing. Yeah, also too. Entities tags. So queue. Where are the queues? So let's see if everything had deployed. And for sure, you won't have anything here. You need to try to show to the camera some stuff and hope for the best. We put some probability, and And now we can click. Let's see if we are lucky on this. We should have some kind of or I could try to see if I have some stickers on my table. Yeah, I have tried also this, something like this. Or this, try to get an issue with the camera used, the cameras from laptop try to get focus on people and stuff like this. And so they are not well focusing on something like stickers, mugs, and here it should help on refresh. But since we have time, I'm going to show you how what was operational, so I can show you preventively the output, how it looks, because I'm guessing I have it someplace saved. That's good. So that will be something saved, but let's first see what we have done with the functions and how the stuff works. Now the visual is starting. Now we'll clean a bit of this. So what you see, okay, since the visual is still starting, even though, wonderful. The function itself is pretty simple. It's a .NET function. It's as simple as it goes. Today, okay, not to lose time. You see that the structure, it's I believe it's a JSON. But what we find interesting, you found the bounding box. You find the timestamp. Timestamp. Let's keep it. Enter. You have the label. This was using the Intel model. So it's person and it's the confidence. Confidence, it's in this manner. I use it without a filter. It's 0.60. It's something like 65%, 64%. And this is how it goes for everything. You have attributes, bounding box. But here you have the corners and the white and the height. And timestamp and label and confidence. So this is what you get outside of this whole mess if you're working with HTTP endpoint. As you gather, this is GDPR compliant. As you gather, this is pretty clear. This will happen even if you're running the ChatGPT models. So essentially, it's now, you know, a prompt, you need to get it around. This is pretty clear, pretty simple. You need to, you can just process it somehow. And let's see the function. Yeah, I'm one of the strange people who are using the white Visual Studio. So this is the whole function. Has an authorization and it writes everything as it gets into the service bus. The only maybe yeah, nothing out of the ordinary. You see my share access key to the service bus, but that's another. It's the simplest HTTP triggered function which it is. Let's try to get back to the wonderful time, and let's try to do a refresh. See if we are lucky. We will try at the end to try to get the model so we have it. He saw something in these 10 seconds, so it was above. We do not see the where is the bounding box. We can go to the storage platform and look that. So let's see in the service bus. Here we should have let's see, pick from the start. Did not recognize here anything. Unfortunately. But now let's continue to part of the problem that we have. How I say, between frames, to recognize this the same object. This is approached in two ways. Sometimes the model itself knows. And sometimes you need to play with what you get. And we've seen what we're getting. So is this bounding box and the label. And it is okay. If you are looking, you'll find it generally on the topic of object tracking. You find again mathematics thrown at it quite heavily. I'm going to show you a couple of things. I'm going to say most of these topics now, they are very actual because if you are tracking a drone, if you are tracking a bird, and because it's a war on and the drones are on, the automated machines, you find these tidbits of why they are doing this until you realize it's a military application or a military wannabe application. Also, it makes sense when you're tracking a vehicle. If you're tracking a person, if somebody tries to jump a door, you need to know it's the same person if there are two persons. There are applications, but now this area really got interesting. This again, I'm trying to. There are a lot of papers, but let's say the most common one is the Kalman filter. So this plays with mathematics to somehow show you there's the same object. It's very smart because it takes into account also the background. So essentially something that you could, and maybe you should run on the model. I would say also on you see on the skill, there is the additional step. That will be running a Kalman model. Also, it's this Canada Lucas Tomashi, a lot of mathematics and a pretty heavy one, and you understand that this kind of mathematics, it's hard to move into code if you're not doing it in MATLAB. And yeah, there is YOLO. With YOLO, you can do it pretty simply. And you have a couple of projects that work with this. And there are a lot of documentation around. object tracking is something that you can, you will most probably need to do. I'll give you the simplest example. The simplest example in my case was, again, I was doing for a demo session, for a presentation, for a conference, wanted to count the people in the room. So as you've seen in the unfiltered model, the model found a lot of bounding rectangles. That was one of the issues. Okay, we filtered out. But also the bounding rectangles for a person, it's shrinking, growing, it's get obstructed. Somehow you need to see the distinct one and also do it across several frames, because if I move the head, maybe the model will recognize me as a person, and so on and so forth. Here my approach was try to see to number across 5 frames the centers of the bounding box. And if the centers are the bounding boxes, the geometrical centers, do not move more than 10 centimeters in radius, it's the same person. Yeah, again, I'm avoiding mathematics, getting on the practicalities and the power calculation. So here are some ways of not doing the heavy mathematics and get good enough result. Good enough versus, yeah. Other idea was, again, to see if the corners do not move more than 10% or something. Again, it's pretty easy to see between. It's not that heavy mathematics. Then I started to look at areas. So essentially, center do not move, and area it's consistent in 10% that it was before. And the other variation was with the corners. Again, corners and area of the bounding box. Because essentially in my head will disappear but won't shrink that much. Even if you get occlused by somebody else, still my bounding box won't shrink that much. And this doing to a couple of frames. The best results, the combination between getting a good enough result, a usable one, I've said not perfect, but perfect, you should dip your feet in mathematics. And now I've seen even using MATLAB to do all this wonderful stuff and get it right. The best result I got it with the center of the bounding box, and 10% with area. In my use case. Bear in mind, I've said that in between frames, some of the objects won't be recognized. So you need to take more than one frame and treat it as such. So treat a couple of frames and to work on top of them. If you ask yourself how you're gonna see that, you're gonna see by timestamps. Because again, I'm working with this strange output that I get. So this, I'm getting this output, I'm buffer it, I'm breaking apart, I'm getting bounding box. I'm creating my objects, so which are pretty simpler Visual of C# classes, because C# it's the tool of my the tool of choice. Because if you are a hammer, every problem it's a nail. Yeah, you can use it in Python case, whatever, but on this I'm very fast, so I'm processing this into objects, and then I have methods to calculate this, get the list of objects and get the number or get something. So in the objects knows the bounding box, the center of it's calculated automatically when you set bounding box, the label, and you're playing with the lean queue, you are getting somewhere. Again, it's not perfect. Okay, what else it's here to know? If you're running on the edge, hardware acceleration, it's in fact not hardware acceleration, in hardware inference. Specialized chips are very nice to have. Like it was, I'll show you, the Movidius chip, which it's now pretty old and pretty past his prime. The NVIDIA chips, yeah, that really helps. And bear in mind that you can find servers with this kind of chips. So you can run the CON or the clusters from something else and still have the hardware acceleration that not hard, I'll say you can do inference on the chip. What's inference? It's running the model on this specialized chip instead of doing mathematics. Here, a lot of stuff got, let's say, somehow lost. I will mention Intel that Intel, they try to optimize the model very much to get the numbers in the right format for the processor and the right size. A lot of this. The approaches I mentioned are quick and I won't say dirty, but get the job done, but they are you are getting you are losing something like 20% of the performance. You could do it far not far, you can do it more perform. But for the normal cases, if we are talking about processes that are the most common, like a car moving, a door opening, people doing something, it's pretty okay, especially when the memory and all the stuff that the hardware, it started to be very, very, very powerful. So I'm absolutely surprised how much power is packed now into a laptop. So yes, you have power to spare. To round it up, the training, yeah, it's nicer to be done in the cloud and some other places. Yeah, some of the services, the one from Microsoft that I know knows to go to graphic boards, and the servers, yeah, they are optimized, and they will get you faster training times. About ChatGPT, I should now say ChatGPT Vision. Now it's pretty new. I'll say the biggest issues that you need to get around, it's hallucination. In Khan, you see it. In fact, you do not see it because the models which come from the zoo of ChatGPT, I'm not going to show you because I do not have the free, all the stuff, in fact, of free sponsored by Microsoft or whatever stuff to be able to create this kind of models in the efficient, financially efficient way for me. But it's still new, but it works if you bear in mind the hallucinations. This is the I'll say the biggest issue. I'll say Khan got around getting calling the model, knows the models from your subscription. You need to put your OpenAI key when you're setting up if you want to use it, and yeah, it somehow generalize this. Getting one step back, if you really are into, let's say, Python, whatever, and you like to call these services, you can do it. What I'm showing you, it's a faster way of doing it. Even with the quirks of Khan, which it's, I'll say, if you live through setup, which it's okay. Even if you are absolutely newbie, I'm guessing in one day you get around. Then if you do not delete, if you do not edit and just delete, it will work. And I've seen it in the production and use it before. It's not a spring chicken. Can it's around for something like 3 years. So there are stuff in the production running on top of it, and it works. And it's again a fast way of developing stuff. It's not the only one. It's the one that you get faster to some kind of results. And since we are in the last 7 minutes, let's try to somehow wrap up, and then we'll maybe play a bit with being patriotic on the topic. Custom vision, it's one of the parts of artificial intelligence that it's here now, and it's really usable. If you are okay, in Croatia, it's maybe not the right example because it's not there. But let's say in Austria, let's say in Czech Republic, the number plates, or in fact, I've seen in Serbia and all over the malls, now the numbers are read from normal cameras. Sometimes that was something like 3 years ago. It was a special chip to understand number plates. But now it diversified. So essentially it became that stable and that, and I never saw issues with number plates, not even in Serbia, which are pretty strange. The models are pretty reliable. This is one topic. So essentially, getting data from the camera running models it's reliable. Second, we have wealth of cameras. So it's something that we can use. From the stupidest example which I gave, it's to write a thermometer, to getting stuff done. There are some other issues from access control, jumping doors, optimize production, calculate velocities of something. A lot of stuff can be done with this wealth of data, which now goes, the surveillance camera data goes essentially to some, I would say, in some cases, even to tape. And for what? For a nice Friday evening viewing, no insides, almost anything, it's taken out of there. And it's a wealth of stuff that can be done. And compared to the other ChatGPT, especially, which, okay, summarizing, creating a template, a presentation, which are hit and miss, various copilots which are good, but they are not that much autonomous. On this, on vision, there are more interesting scenarios to be have. And I'm saying more interesting because here it's more definite result. If I'm getting a code generated, it will be compilable, but that doesn't do the job. Here I'm getting some insights with the probability, which it's much more much easier to be used or to be discarded to verify. So getting back, all the stars are aligning. We have the wealth of information which it's somehow around, and we have the technology which it's the most mature from in the artificial intelligence world. And it's to be used. And there are easier way. I would say, you got it. I'm Romanian, I'm lazy. I found the easier way. And there are two big approaches, let's say normal machine learning, which we see how it goes, and try to leverage some generative models, both with pluses and minuses. You have tools that can combine them all, and you can create a lot of plus stuff on top of all this. This being said, and we're having 2 minutes, if you have any questions, until I'm still trying to jiggle the model. Let's see. And funny enough, some of the picture of these stickers, I use them for training, but I will blame the camera, because the camera it's looking for a human being. Oh, in fact, let's try this. Now, using this minute to look into the Azure portal if you have something here. Nothing, and let's see on the card if you still have something. If you have still another recording. Oh, we have another one. Let's see what, if it sees something. Recognize something. But let's see what was the something. Also, the lights do not help how I have them set up. And also this player, there are, so this shows the model it's working. Most probably I did not put correctly the endpoint if we do not have any messages, because it's 078 and it recognizes the stuff and have a nice bounding box. So this being said, we are on the end of our time. If you have no question, I'm going to thank you very much for your time, and looking forward to see you some other data science conference. Hopefully, let's do a hackathon or something, because okay, now it was a bit. I will tell you about my experience and my tribulations with it. I'm looking forward to hear from your experience and to learn, because this is how you learn. I've been to another, as Alexander mentioned, I've been to other data science conferences and I learn about these topics. I learned that exist and I try to dabble into them and get something useful, and also to help me in my work and help the customers that we serve. So thank you very much.